My name is Francis here. Investing analyst, as you guys know. Mostly tweet about technology, the AI, ML space, cybersecurity, whatever. It's just a space that I really enjoy. My background primarily comes from working in around data science projects and leading those data projects for the most part. Um, that's where a lot of my background. So I worked at a financial institution, one of the largest credit unions in Canada, where I'm from here. And a lot of my responsibilities on the team was leading our data science project. We were a brand new team within the bank. The bank was undergoing a digital transformation, and they eventually were moving over to the cloud, and from the cloud they wanted to move over to Snowflake. And so we're in the process of adopting the Snowflake platform, and I joined the team to kind of I played my role as more of a product manager or project lead. So I was working with data scientists, data engineers, governance architects, solution architects, as well as your developers as well too. So that was my work, and that's kind of where lots of my experience comes in. And so yeah, AI ML is actually my core area of technology, where I have the most experience. So I'm really excited to have these conversations with Convequity. So I'll just let you, Jordan and Simon, maybe just introduce yourselves for the crowd, just so they know a little bit about you guys. And then after that, I just want to give you guys an overview of what we're going to be talking about today. I think we're going to begin first with just giving kind of like a general overview of the data space, of kind of just what the data machine learning space looks like, just for people who are new to this topic, just demystify everything at once. And then afterwards, we're going to go into the key trends that we see happening this year, what's happening in the enterprise, what's happening with Snowflakes and Databricks, what's happening with the likes of Palantir, Confluent, and pretty much all the trends that we see that are evolving in this industry. So before that, we do the introductions, we do a high level overview, and we get into those cool topics. So perfect. So yeah, maybe Simon, you get going, just introduce yourself, and Jordan, introduce yourselves.
Yeah. Hey guys, it's Simon here. So I started involvement with the technology from the consumer electronics side, and then expanded into the cybersecurity, and then a little bit of enterprise technologies and the SaaS overall. And just find it very interesting to be talking with Francis on his experience with the data science and the AI in general. And I feel like the public investors are not well aware of this trend um, in more detail, and it creates tons of bubble names, but it also provides tons of opportunities for intelligent investors to have an information edge. So yeah, very cool to discuss with Fancy on the topics related to AI today. Yeah, hand it over to you, Jordan.
Right. Thanks for that, Simon. Yeah, I'll be very brief about my background. So, I've my background originally was working in the financial industry, working as a broker for a few years, and then as a financial advisor, and then I switched across to being an analyst, an independent analyst. Um, and really, it's gone from there. Really, a few years I started working as an independent analysis, and then got more and more interested in the equity research side of things, and a lot kind of reached out to some interested people who would be willing to join me and begin Convequity a couple of years ago. And I found Simon, and he joined, and we set up Convequity together. So we've been running Convequity for a couple of years now, just focusing on enterprise software primarily. And yeah, so that's in a nutshell, that's my background and how we got to where we are today. So yeah, Francis. I mean, back to you, Francis.
Perfect. Thanks, guys. So let's kind of just get going here. Let's for people who are new to the space and people who don't understand enterprise AI and just the machine learning landscape. Maybe let's give kind of a brief overview, kind of a brief introduction to the whole space. Do you guys want to just give like a general overview of the space and maybe a little bit of history? Just kind of
Yeah.
so we break down the walls for people here.
Okay.
Okay.
Sure. I'll take that. I mean, perhaps before we dive into covering the brief history of AI and machine learning, maybe it's useful for the listeners to just touch on what a neural network is, and deep learning neural network, because that is kind of the main area of focus in machine learning at the moment, and that is why so much data is required. So neural networks is I like this explanation that I've seen a couple of times. A neural network is essentially a hierarchy of simple concepts that are combined together in order to make more complex concepts. And a classic example is the image classification problem that machine learning models often take on, where they have to take in an image, take in the pixel values of an image, and they'll put that into an input layer. And when I say pixel values, for convenience, let's just say it's anything from 0 to 1, depending on the brightness of each individual pixel. And that information will then go into the first neural layer, and that neural layer will determine, take a look at individual pixel values, and then look at the neighboring ones and determine where the edges are. And then that information will go into the next neural layer, and that layer will use the information on where the edges are, look at adjacent pixel values, and then determine where the corners are. And then this kind of goes into the upper layers until the machine learning model can predict major parts of the image, and therefore and eventually predict what the image consists of. So that is in a nutshell. For me, I like to understand neural networks like that, because it's just a hierarchy of simple concepts coming together. The simplest of concepts being the raw pixel values, and then the corners and edges, etc. And so if you can get a good understanding of that, then I think that'll put you in good stead for understanding machine learning, deep learning, neural networks more generally. So a brief history of neural networks. I mean, research began back in the 1950s around neural networks, and over the decades there was quite a lot of progress, but it was always limited by the available computational power. And then, kind of in the 1990s, I believe research into neural networks kind of faded a little bit, and the machine learning scientists were looking at other types of machine learning models. But then neural networks had a rebirth in the mid 2000s, thanks in large part, well, predominantly because the internet was in full force. So we were generating more data. We had the mobility thanks to smartphones. So again, we're generating even more data. So it was kind of the beginning of the era of big data, and these neural networks rely heavily on very large data sets. So that was a key dynamic that kind of rebirthed neural networks, and more specifically deep learning neural networks, because deep learning neural networks just requires more layers within the model. And then obviously we have a boost in computational power as well, and also a kind of a shift from the CPU to the GPU, where well, in the 1990s, gamers were using the GPUs like they are today, and machine learning programmers was trying to tap into the power of the GPU, and tap into that parallelism, and tap into that matrix multiplication that the GPUs can give. But initially, it was difficult for machine learning programmers to do that, because they not only did they have to be specialists in machine learning, they also had to be specialists in the hardware. So it just wasn't very accessible. But a key turning point was in the mid 2000s. Hello? Hello?
Hey, Jordan, I just thought that we had a connection issue.
Right. Yeah. Are we back on now?
Yeah, I think
Yeah.
so.
For some reason it just disconnected. Apologies for that.
I just very quickly, I just have to tell everyone, like, I mean, just expect this to happen as we go through this. It's just, it's quite frankly just part of being on Twitter Spaces, is we're always gonna have a phone breakout or a connection issue. So just FYI, everyone, just in case we disconnect, we're always gonna make sure we get the spaces back on again. So,
Okay.
so
Right.
Jordan,
So that's the
if you could,
yeah. Well, sorry, where did I get to before we got disconnected?
I think the discussion around the breakthroughs during the early 2010s.
Oh, right, yeah. So I mean, a kind of key milestone was in kind of mid 2000s when NVIDIA introduced the CUDA programming language, which was kind of an interface that allowed machine learning programmers, just normal programmers, to access and harness the powers of the GPU to tap into that parallelizable component. And kind of, I think that was a key milestone because it just made computing, it's kind of fitting these deep learning neural networks on a computing infrastructure that was capable of dealing with it a lot more accessible because we could use the GPUs. And then kind of in the 2010s, to kind of support that momentum, we saw machine learning software frameworks come out, such as Theano, Caffe, PyTorch, and then TensorFlow. And just the general kind of open source nature of machine learning just means that machine learning programmers don't need to reinvent the wheel every time they want to do a new project. So all these factors kind of propelled the industry forward during the 2010s. And kind of more recently, we've seen chip developers create specialized hardware for machine learning. So it's kind of like 20 years ago, machine learning was adapting to the hardware, and now we're seeing that the hardware is adapting to machine learning, well, especially in the last few years. So I think I think right now we are at an interesting turning point in machine learning because, as I say, hardware is being specially made for the industry, and it should propel it further. So that's just my brief overview of the industry. I mean, Simon, do you want to add anything?
Yeah,
I think,
yeah. I
and
just want to. All right.
very quickly, Simon, just very quickly. Thanks, Jordan. I think, Simon, I think where I'd like you to maybe speak on a little bit is just if you could touch on a little bit more on like let's break down some of those definitions for people who are non-technical. So, if Simon, if you could just provide like what's a machine learning model, like what's a data science model, like if you want to break down a little bit more of those pieces, just for, I mean, we all know what those technical terms means, but let's maybe give that. I really want to make sure the crowd has a good foundation of just those key terminologies, and then I could maybe talk to the enterprise stack that I shared up on my screen here. So thanks,
Yeah,
Simon.
yeah. Just very briefly on machine learning. So previously, if you think about when we are doing the coding, um, we we have to make sure that we understand the logic behind each steps that we are doing the programming. But with machine learning, we are asking the computer, the machine, to learn um, a few trace from a huge amount of data set, and then it will just trying to fit into a certain standards, a certain criteria that we ask the machine to learn and save that kind of pattern, that deep pattern into the model, and then the machine learning model will make predictions. So that is the kind of the black box feature of the machine learning model. And what's interesting, I think, is that in the early 2010s, we had that the first paper called AlexNet that was a very big breakthrough in the computer vision space because if you think of there is one test called ImageNet whereby um, machine learning models are evaluated based on their accuracy in sorting out which breed of a specific dog it is. And you have like more than 3,000 breeds of species. And for a normal human, you expect accuracy like 90%. And in the early 2010s, the accuracy rate for various models were like more than 70%. But what we have seen is that there is a radically reduced error rate from the machine learning space since the 2012 AlexNet, which reduced the error rate dramatically into the 20% range. And then we have a very steady growth in terms of machine learning model. Fast forward into 2015, we have the ResNet, and then we have Transformer in 2018. And you can see that momentum really kicking in with the accuracy rate from 70% into 80% into 90%, and now we are close to higher than 95%. And that is really a inflection point because now the machine can really beat the human being in the tasks that are associated with the consciousness. And what's more is the training cost and the performance that we need to deliver this kind of machine level consciousness is getting lower and lower. So if you think about the amount of compute power back in the 2012, it was the AlexNet was trained based on two GTX 580 NVIDIA graphics cards, and the layer computing power was like 8 teraflops per second. And now, if you think about the state of the art NVIDIA like Ampere GPU, it is like more than 1,000 teraflops per second. So that's a huge performance improvement from the architecture side. And then we have few tricks around the data types, whereby we can reduce the precision of the data while dramatically increase the compute power. And the final piece that create that serves as the catalyst is the parallelization that is largely enabled by the transformer model published by Google back in 2018, which allows you to train the model with more than like 1,000 GPUs at the same time. So I think architecture and the data types tweaks and the parallelization have empowered us to train the MI model with more than 1,000 times compute power growth over the last decade, which is significantly better than the Moore's law. And I think this is also the backstop for the growth of the AI industry, as opposed to others like the general compute, where we have seen just like around 10% compounded average growth in terms of computational power. So I think that's the biggest backstop for the AI.
Hello, Francis?
Yeah,
Have we,
yeah,
have
I'm
we,
good.
have we lost Simon there, or did he?
yeah. Hand over to Francis.
Right,
No,
over to you, Francis.
that's perfect. That's perfect. Thanks. Thanks, Simon and Jordan. And so with this first part of the spaces, I just want to make sure, like, if anyone's into the very technical, as I said, Jordan and Simon are very deep experts into whatever they do, and thanks for that. Just giving us that introduction into just the foundational parts of what's enhancing most of the modeling success and breakthrough that we've had over the last couple of years. On my own part, I think I'm just gonna speak very briefly to what I'm sharing up on my kind of what I have up on the spaces. Think of it like your PowerPoint. But I think I'm gonna speak more to the enterprise side of machine learning models. So Simon and Jordan have talked about the underlying technologies, the chips that are actually underlying most of these technologies, and I'm going to speak more towards kind of what's happening on the enterprise. And so, in general, I want people to think about AI as being, think about it like like a complex, like a system or a human being or a file, whatever you want to think about it, and then training that complex system with huge amounts of data and using algorithms then to train. It's like almost training a think about it like a dog, training a dog to recognize certain patterns over and over, and you train that dog with different types of data sources, and then provide it with an algorithm and just allowing it to learn from that to become eventually intelligent. And so on the left side of what I'm sharing on that overview of the modern enterprise data stack, if you want to call it, is you have your ordinary data sources. And this is what if we go back 20 years ago, the modern organization looked like your event data, your external data imports, your applications like your Oracle, your Cisco, right? You had your traditional systems, and a lot of that progress that machine learning have allowed us to do then takes us towards the right side of that modern data stack, whereby now we're able to have better tools like, let's just DBT and the likes of Hadoop. Hadoop was the early guys, they were there a few years ago, and now they're kind of obviously fading off with the likes of Databricks and Amazon S3 now. And what you have is the way your traditional company looks like is you go from your ordinary data sources, you do take all of those data sources and you ingest it using some of those pipeline orchestrations like Perfect, processing integration tools, and then you dump those into like your data storage or your data lake or your data warehouse, or sometimes the data warehouse like a Snowflake, Google BigQuery, or whatever you have them. And then once you have them in there, sometimes and most of the time there's a lot of data cleaning, storing the data in the right places you need, cleaning the data, making sure there's a lot of actually a huge part of data science actually goes into the data cleaning and the data cleaning, quite frankly, and the cleansing. And once you go from that whole process, that's when you have the analysis and you have the modeling, and that's where you have your data scientists doing a lot more modeling, manipulating the data with the goal of generating some kind of an insight. And then from there, that's where we go all the way to the right, to the very right, where you have the analytics and BI tools, your real time analytics, and your data science. That's where you get the real predictive analytics. Because going back to what I mentioned earlier on, you've grabbed all these data set, you store them or you've ingested them properly, you've integrated them properly, you've cleaned out what doesn't need to be as necessary. And then now you're able to train your model. And generally, from what I've used in the past, you have different kinds of models like deep learning, which Jordan spoke about. You could do a supervised or an unsupervised model. Really, honestly, just it really just depends. You could be solving a different problem that has to do with like a classification issue or machine translation or natural language processing related kinds, or you could be doing something around image recognition, kind of what UiPath and the likes of the RPA too. Well, I don't want to go too deep into that. I just wanted to give people an overview of how the modern data enterprise AI looks like in the actual corporation, going from the left all the way to the right. And one last thing I'll just mention with the chart above is for each of those sources, the most underlying to everything, think about it like the foundation to everything is your cloud. You could be on the cloud or it could be on-prem. And then that's where and then from the cloud, that's what powers, it's kind of like the foundation to most of these. And then you have your ETL processes and the likes of those. So that's kind of just a general overview. And I'm going to invite some people at the end of the spaces to maybe speak more to some of these trends. So maybe let's go into more the trends of what we see happening this year. Like, so one trend maybe we could begin with is
Maybe I can jump in and before
sure.
we start diving into the trends, maybe just to add a bit more color around AI. So I think there are two ways to understand or just to understand the AI in the context of investment. So I think there are two misconceptions here. So the first is the definition of AI. So I think when the public investors think about AI, they're just thinking about a very all-encompassing, far superior than all human being like AI. And actually, we call that AGI, artificial general intelligence. But what we are talking about AI here is really use the machine learning models to fit into a huge amount of data set and then use this kind of black box tricks to optimize for specific tasks. And I think there are three big areas. The first is the computer vision, whereby we can use the machine to understand the imaginary information better than the human being. So that includes things like Tesla and the UiPath, as Francis alluded to understand the image better. And then we have the second, which is the NLP, the natural language processing, which involves things like translation and the speech generation that we use pretty much often with Google and other services today. And the third part is kind of recommendation engine and optimization things that includes things like a lot of things that we use today as well. It's like the Google search, or the Facebook or Twitter and TikTok, that kind of recommendation and engine that are able to understand you better, understand you the content that you like. So that is one way to frame the AI space. And another way to frame the AI space is just as Francis talked about, is about the tool chain. So if you think about how you are going to use the AI into the real production, you need to get high quality data, and then you need to clean the data to make sure that it's ready for training. And then you have the part of the training process whereby you fit into a model, and then you have the inference stage whereby you have trained a model and then you want to put it into the real use. So that's the inference part. And then finally, it's kind of related to the um, end user part. You have the visualization, and you have the final stage to make sure that the predictions made by the model is um, able to generate valuable business insights. Yeah, and Jordan, maybe we can start talking about the recent trends for the investment for the AI.
Yeah, thanks a lot, Simon, and thanks a lot for clarifying that and just providing that extra context. So I think with the investment side, there's different areas in which for investors to think about. And when we talk about trends, as I mentioned early on, they're like your foundational machine learning AI companies. Kind of think your foundational companies, like think about them as more like your AMDs, your NVIDIAs of the world. You have the enterprise side of things that includes your likes of Snowflakes, Databricks, and then you have those are more you maybe call them horizontal AI companies, and then you have your vertical AI companies, whereby you're using AI to solve specific problems. So, for example, Stitch Fix uses AI to solve problems in clothing, or RPA, right? You have things like what the companies like UiPath are doing in the low code, no code space. But specifically, maybe the first trend we could talk about is just Snowflake and Databricks. So one major trend, and this is a trend, this is even a report that I read from ETR Research. Maybe that's where we could begin our conversations here. It's just um, one of the biggest trends has always been the conversation about data lakes versus your data warehouse, right? And so for people who are just not new to this, but I mean, when you think about your data warehouse, you want to think about it as like the foundation or storage place where you put in all of your data that you need in an organization. So it's almost a place where it's think about it like a river or think about like a warehouse, quite frankly, where you could store all kinds of data, structured data, unstructured data. Most of those things on the left side of the stack that I showed up, the data sources, you could kind of throw them into this bucket of your data warehouse. Meanwhile, more your data lake means think of it more as it's also a similar concept to a data warehouse, but it's the same, but it's a much more low cost where you could put in raw data. So it takes in all kinds of data, whatever you need, and you just dump them into this one place. And then once you dump them into your data lake, they then become available for you to create insights or to for your data scientists to do analysis like what Palantir does. Palantir would rely on a good data lake or a good data warehouse. And I think one trend that I've read about, and I'll be happy to hear you guys' thoughts on this, is just more around what's happening with data. Snowflake has built the data warehouse, that's their strength, and they're transitioning over they're wanting to become more of a data science, data analytics platform. Meanwhile, on the other hand, Databricks, we know Databricks is more of a data science platform, right? They invented the whole concept of this whole data lake that they do, and they're also trying to move maybe more into the data warehouse side. So it's like these two companies are kind of taking two sides of the coin, That's one trend that I'm watching with those companies. Do you guys have anything to add in just terms of what you guys are seeing trends from? It's this whole notion of the storage and compute platforms of Snowflake or Databricks.
Yeah, yeah, I find it very interesting that Snowflake is really disrupting the data warehousing industry. And previously, we also have a data warehouse, but it just seems like the product is so organic that people are really shifting their existing spending on for the on-prem products into the Snowflake. And I think what's more interesting is around Snowflake. I think there are two. The first is really just about how easy that it is for developers to use. Maybe Francis, you can share your experience with Snowflake as well in your previous data science projects. And the second part, I think, is about its consumption model. So actually, it's um, Snowflake is based on infrastructure as a service, kind of cloud infrastructure based on the AWS and things like that. But what's interesting is that AWS it also has its own kind of data warehousing solutions. Previously, it's called Redshift, and a bunch of other services, but they failed to deliver this kind of multi-cloud and the consumption-based model whereby you are charged only based on the number of the amount of data that you saved here. And what's very interesting about Snowflake is that it helps developers to connect multiple clouds, including their on-prem data, together in a new abstraction layer. So that dramatically reduces the amount of resources and energy that you really need to put all other database together. So I think that's a very promising part of the story. And then I think we are very early to that transition. And I think that's also the point where the public investors are not well aware of. So maybe Francis, going back to you, what's your thought on where we are in terms of transitioning into this kind of cloud native new orchestration layer to connect all the underlying database together?
Sure. I mean, where I worked, for example, like the financial institution where I worked, where we were transitioning over into a data snowflake or a data a, d- a snowflake platform, sorry, a snowflake's data warehouse. I think with our experience, one of the good things that Snowflake has done that many companies, especially Oracle, who conquered the database data storage market for decades or even longer, quite frankly, is what they did really well. They've always had the data warehouse, the data storage part of what they've had. But what they didn't have was what Snowflake brings to the table, which is a storage and a compute side of the platform. That's one of the big benefits that Snowflake has innovated, quite frankly, and being able to do all of this in a cloud and this abstraction layer in a cloud agnostic fashion whereby you don't have to be on Google, you don't have to be on AWS, you don't have to be on Azure. It's a cloud agnostic platform, but you have a platform where you have a storage element of the data as well as you have a compute side, and you have both running those together, and you could control how much capacity you use. You could kind of dial that up or you could kind of dial that back depending on how much it was. And then it's a pay by use, right? And so that's the consumption part of it, quite frankly, where if we feel like, hey, we want to turn off our data, maybe our office, we're going on a vacation or whatever, we don't provide services over the summer or something, then we can kind of tune down how much we're paying for storage as well as compute resources to Snowflake. And this type of flexibility, quite frankly, hasn't been done successfully by other big players on the market, like your Oracles of the past, your Clouderas, your Hadoops of the past. We've never really had this type of innovation. And I think that's one of the biggest reasons why Snowflake is quite in demand. At my institution, that was why we went with their platform because traditionally where I worked, we were on-prem. So we used a lot of on-prem. We were on-prem for the most part. But then we were moving over to AWS gradually. So we were kind of using a hybrid model where we had some data on the cloud, we had some data on-prem. It was kind of scattered all over the place. And our data scientists, quite frankly, and our data engineers had problems kind of toggling back between both data sources to be able to build their models and create just really effective model. And so for us, the most logical step was moving over to a Snowflake platform where you could literally just have all of your data stored on the cloud, and you could also do your compute resources. And then they had this data warehouse where everything was just centralized. And then the cool parts with Snowflake too, it's a managed service. So in the past with your Oracle, you had your Clouderas of the world. There's still a lot of maintenance you need to when you store data. There's a lot of maintenance needs that actually comes with that, right? Making sure it's properly, making sure there's no security issues, making sure you're closing all of those gaps. But with Snowflake, it's a managed service, so that means Snowflake takes care of everything. Like, all you just have to adopt the Snowflake platform, and then your data just gets automatically stored, and it's kind of like this automatic managed service. So it reduced a lot of cost and maintenance for our company. And so, quite frankly, I think these are some of the reasons why Snowflake is so in demand because, quite frankly, not many companies have done this as successfully or executed as well as Snowflake has done. And I think that's why it's still in so much demand. And quite frankly, I see spending continue to ramp up over the next year. But I want to hear what Jordan or Simon, whatever
Yeah, sure.
you
Um,
guys. Just very
yeah, I mean,
quickly,
I
right
oh,
after
sorry,
that, just very quickly, Simon, just sorry to cut you off. After you, Jordan and Simon, after you guys speak, I'm just going to invite two other speakers to just come give their opinion. Some people that I know who have worked in the field as well to kind of bring. But go ahead, Jordan, and I'll get you, Simon, and then we'll move there.
yeah. So I'll kind of echo what you guys have been talking about in regards to data, and then I'll just also tie in a bit of Palantir to that as well. So, I mean, yeah, absolutely agree with what everything that's been said. I mean, data access and kind of just data on the whole is absolutely paramount. It's kind of the fundamental building block for machine learning and developing AI. And a lot of these companies that have hybrid deployments where they have a lot of uh, uh, information on-prem and also in multi-cloud environments, especially for the likes of data scientists trying to tap into this information and do any effective work is nigh on impossible to do really effectively. So
Hello? Just to check if we lost the connection.
Jordan, if you just want to wrap up, say those final words.
yeah,
You
yeah.
had some
Hello,
final
hello.
words that you cut out of.
I'm back.
Yeah.
Wow, sorry about that. Second time it seems to be when I'm talking, so I'll try and keep this brief. Yeah, so obviously the use case for something like Snowflake, where you get all your data into one area where data scientists and other analysts don't have any restrictions in terms of making queries. There's not going to be any bottlenecks, and they're paying as they go, as they consume resources. And also, Francis, what you mentioned earlier about the kind of a key competitive advantage of Snowflake compared to like others is them being able to separate the storage and the compute. That is a critical competitive advantage. Um, so yeah, Snowflake, great prospects. But I like to. I've been contrasting Snowflake to Palantir recently, and it's kind of with Snowflake's business model. They are purely cloud native, and it relies on companies transferring all their data onto a cloud. But with Palantir, it's kind of like Palantir's taking their software to where the data is. So it's kind of there's a lot of overlap between Snowflake and what Palantir can do, but the way they approach it is quite different. So for the companies that are very fragmented across hybrid deployments, but they don't want to commit to transfer all their data to the cloud, I think Palantir is probably the best bet. And yeah, I just generally think Palantir is quite misunderstood. I mean, they've me and Simon's been speaking about this a few times in the past. A key the key advantage for Palantir, what probably isn't discussed a lot, is their ontology layer, their ability to, well, first and foremost, Palantir go into companies and they install the Foundry operating system, which is a competitive advantage in and of itself, because not many software companies do that, if any. And then once the operating system is installed, they apply this ontology layer. And basically, what an ontology is like it's a shared vocabulary or a shared language. So, kind of groups of concepts and their constituent classes and properties, etc., can communicate with each other. And you see ontologies everywhere. We just may not be aware of it. For instance, the internet is predicated, is based on various ontologies. So, for instance, that when we're searching for something, we can access the information that's on web pages without a common ontology, which is something like the RDF, which was created by the World Wide Web Consortium. We wouldn't be able to, our search engines wouldn't be able to retrieve information from web pages, etc. And also, like you get ontologies like in the healthcare industry. So there's diseases and illnesses can be codified, so they can be understood across different IT systems, like the doctor's IT system, the pharmacist's IT system, insurance IT system, and across national boundaries, etc. So it's that common language, which is an ontology. Um, and what Palantir does, in effect, is go into these companies that have disparate, disjointed IT systems, which makes it very difficult for the likes of data scientists to do any effective work and collect all the data that they need in order to help the business make good decisions and develop machine learning models, for instance. They go into these companies and put this ontology layer on. So now every kind of data that was previously siloed is now searchable, reachable, retrievable. So I really don't think that competitive advantage is commonly understood, because, and the reason it is a competitive advantage is because doing an ontology is extremely difficult. That's why kind of these ontologies are only being attempted by consortiums of entities like the World Wide Web and others, because it is really, really difficult for a single entity to implement. A popular ontology across social networks, for instance, is the friend of a friend ontology that allows people to search and connect with people across social networks. And obviously, big tech have their own ontologies, like Amazon, in order for people to easily search for products, etc. But typically, companies don't create their own ontology or don't do it for other companies. Whereas Palantir, that is their business. That's what they do, and I don't see anybody else doing that. Simon, I don't know if you want to speak a bit about Palantir, because I know we're both very, very bullish on Palantir in the long
Yeah,
term.
yeah. And so I think Palantir is just a very unique company that is very much misunderstood by the public investors, and more importantly, the sales side investment bank analyst. And I think a huge part of it is just its moat. And I think it's moat in the hybrid cloud, and the ability to solve the kind of legacy enterprises problem, I think is very huge and it's very real. And I just think people are just not aware of Palantir's work over kind of it's called software defined data integration that is going to help connect all the siloed databases all together. And I think another part of it is think about the scalability and the margin profile. And very interesting to see that Palantir is able to achieve the contribution margin of higher than 50% for tons of early customers. So that shows that they are just not using the kind of human labor to do all kinds of projects like a typical consulting company would do. And they are able to um, automate tons of repetitive tasks with machine learning and various models instead of the human work. So I think that is a very promising part, and really investors are missing. And I'm seeing tons of investment bank analysts citing that kind of lack of profitability as the issue. But if you think about the gross margin and its contribution margin profile, that the kind of AI empowerment part is really helping Palantir to achieve higher margin. And then going back to Snowflake, its gross margin is also very interesting because when you are thinking about a kind of infrastructure company that is built on top of another infrastructure company like AWS, which we believe that is a highly lucrative business. And according to our calculation, AWS contribution margin is higher than 60%, which means that when you are buying $1 of storage space, Amazon's raw material cost is lower than 40 cents. So that's how profitable their infrastructure business is. But what's amazing about Snowflake is that on top of AWS infrastructure, it is able to charge higher premium to the kind of generic data service. At the moment, their gross margin is around like 60%. And that is highly profitable if you think about they are built on top of Amazon's infrastructure, which has more than 60% of gross margin as well. So I think that is also a very interesting point where investors are now aware of. And just finally on the moat, I think both Snowflake and Palantir, they are kind of cloud agnostic. And I think that is another point where public investors are not well recognized about this trend, because previously when you are thinking about buying various products from various vendors, you really do care about am I going to able to transfer that kind of data from one place to the other, and can I just get the edge when I am doing the quote with the vendor. And what's interesting about Palantir and Snowflake is that they're able to connect tons of siloed systems all together, that whereby you don't need to worry about which vendor am I going to, and how should I negotiate with them in the future. And finally, I think it's the decoupling of compute and storage is a very big mode for Snowflake. And at the moment, we are not seeing any other guys doing that, and including AWS, which has tremendous amount of experience working with the infrastructure side of the business. And yeah, Francis, what's your opinion about the moat for Snowflake and Palantir?
Could you hear me?
Yeah,
Yeah.
I can hear you.
Yes, absolutely. I mean, I completely echo what you guys have mentioned here. I think there's so many. I think I've already spoken quite a bit about Snowflake's competitive advantage, and just the fact that not many people are able to do what they're able to do at scale. And I think it's the same thing too with Palantir, right? They've built this very unique platform of data integration capabilities, right? The ability to go into any organization and have the technology that's able to integrate so many data from so many disparate places and then put that all together in a centralized location and being able to then build models based off those ontology, right? Those ontology based um, decision making processes that they do have, being able to build models very easily from there to drive business insight. So I think a lot of what Jordan mentioned, I completely echo. And that's another thing that's extremely difficult because and I think this is the thing with Palantir. It's almost like a vertically integrated analytics platform because when you think about all of these companies across the data ecosystem, or even in that picture that I showed you, many of those companies cater to one segment, right? And it's very difficult for you to replicate the other person's segment. But what you have with Palantir is you could pretty much put Palantir in between that data lake, data storage components, your query engine, plus the data science and ML. So if you that modern data stack that I have, you could easily put Palantir across three of those areas in terms of what their platform is able to do. Not to also mention they have security features, privacy, data governance components of what Palantir offers. And so it's very much robust. I think one last thing I'll say before I maybe jump off here, before I get one of our speakers to come on, is it's just the fact that the growth, the penetration of the enterprise, that's extremely lacking in what Palantir has. You know, they've done this very well in the government sector. They've executed upon this really, really well across being like the OS, the operating system for governments. But now the challenge is how do they break into the Fortune 500 system and how do they make their systems a lot more easily able to integrate with, quite frankly, many of the pictures, many of the companies that I have up on that picture on my modern data stack. Palantir has issues integrating with many of them, right? Where they still need more partnerships with system integrators to help their platform easily sustainable with those companies, and that's why we're not seeing the growth in Palantir, and that's the problem. That's why the growth from Snowflake is completely different, and that's an area I'm watching, and I'm very cautious about. They have a phenomenal technologies for the government, but it's how could they get into the enterprise? Because that's where, quite frankly, the next phase of growth belongs to the company. But okay, I think we have Think or Masterly Inactive. Could you also just request to be a speaker, and then I'll just have this. So just we Think just so people know, he's been in the data world as well, quite well. He tweets maybe the occasional time, but he's someone who's been in the data world for quite some time. Just kind of wanted to get your insight. So, think, what do you think about, like, maybe you might want to add or maybe correct or whatever from what we've discussed so far? Are there anything you have to add? And then from what you're seeing on the ground, what are key trends that you're seeing happen right now?
Sure. Thanks for bringing me on. Well, I guess I can't say too much about Snowflake. I haven't had a chance to use it with any of the organizations I was with. But I guess a few things I'm certainly thinking about are, I guess, one, I think every time these technology trend conversations come up, it seems like we're maybe looking too far to the future. Whenever I'm in one of these projects, it's, there are Fortune 500 companies that, aren't tech companies, and they still struggle to do a lot of the basics. Like an example was, I was on a project where they were designing a custom CRM tool only to find out that there already was a Salesforce instance developed somewhere in the organization. So just something to keep in mind. Don't go too far ahead when looking at trends. a lot of companies are going to be pretty far behind. One thing I do know, I have heard about Snowflake is they're not the best at handling NoSQL data. So text, strings, stuff like that. That's something that like MongoDB is known for because they're more flexible. Databricks is also known for that because of flexibility. I'm not sure if they've started solving that problem yet. I am really curious about the Databricks versus Snowflake kind of battle, I guess you could say, that's kind of going on. I mean, I don't know why not both can't be maybe successful as investments. I guess two other things I'm thinking about are anything that speeds up product development. A lot of these companies will be developing their own apps in-house for certain things or data products. I'm not sure what companies are out there that can help speed that up, but that's probably one of the reasons MongoDB took off. It was apparently developers loved it for developing these apps fast. So something along those lines. And then the last trend that I'm surprised hasn't taken off yet is data quality. Everyone loves to talk about massive amounts of data. I haven't heard much at all ever spoken about in terms of data quality. And it seems like a lot of end users ignore it or overlook it or don't talk about it. I guess those are some of my thoughts.
Perfect. I think that makes a lot of sense about Snowflake, and just I think data quality is a big piece. I broke a little bit out from just kind of listening to what you said, but it's kind of interesting you mentioned Snowflake not being really good for NoSQL kinds of data sets or data sources. Yeah, I haven't quite heard that as much, but I could 100% see that being the case. I could 100%. I would need to think that through, but that's definitely a very an interesting observation. And obviously, data quality is always always an issue for data scientists. And quite frankly, one of the trends I actually wanted to talk about was just even the data engineering component of machine learning in the organization. As you guys know, data engineering roles have grown quite rapidly because just for people who don't know, but data engineers you could think of them as being the middlemen or the middle girls or whatever, like kind of that middle person in between where the systems are, your kinds of your Hadoop, your cloud, if you're using a cloud, there are Snowflake, your data lake, whatever that is, with your actual systems that your data scientists need. They're kind of the middleman that they do like the hard work behind the scenes of getting the data out and pushing it out so that the data scientists have good data. And I quite agree that there's a lot of work that definitely needs to be done around how do we make data a lot more clean, because just so we ensure that the data scientists don't spend a lot of time, because that's one of the biggest time consuming aspects of building a model, is just how do you make your data perfect? How do you make it as clean? Because you don't want your data scientists spending so much time on data cleaning. You want them spending more time actually doing their model, doing their classification pieces, and then tuning their parameter tuning and tuning the models to make sure that it's as good as the best performing model. But if they spend so much time doing the cleaning and the data quality side, it's definitely an issue. But I echo that. Anything else to add, Fink? Okay, Simon, if you guys have any point.
I just it just resonates with me very much around the issue about how to get the data first, and second, how to get the high quality data. I think it's a huge pain point for me, and I think for lots of people just playing around the data. And I think it's very it just indicates that we are super early to the journey into the AI and the machine learning, because we just haven't find any great product that can make the user experience, the life of a data analyst easier. As simple as just like you can use one click and get all the relevant data, all the relevant high quality data within one click. I think we are not seeing that kind of solution yet, and I think this is something we will be developing into in the future. And I just think we are super early into this journey. And again, the pain point around getting the data and then getting the high quality data needed to generate the insight. I think, yeah, it's a huge pain point whereby the incoming solutions like Databricks, and then another one called Cockroach Labs, and they have a great chance to address just one single piece of this puzzle, this pain point. It will be a huge TAM for them in the future.
Would you add anything to that, Fink? Do you have anything to add there?
Just one last comment is every software application or data product that's developed needs, like a database. It needs stuff like that, but not every single one needs an AI or ML component. AI and ML are the fun part, but it's only a subset of a lot of the other, only a subset of what products are built out there and applications. So keep in mind that, when you're looking at your TAM, other things might apply more broadly.
Absolutely. And just to even mention, I think another thing we're seeing more is companies like, these are young companies. I don't think many people would know them yet, but companies like Prefect and Airflow, these are very young companies. But I think what we're seeing now is kind of more a trend in open source projects, whereby there are more open source projects aimed at solving many of the challenges we have in just better data, cleaning up that pipeline, making the pipelines a lot more efficient, and just better orchestration tools. And I think young companies like Prefect and Airflow, they're automating a lot of this complexity around getting the raw data out and just smoothing out that process of getting the data from the source and making that extremely more clean and efficient for kind of your data scientists. And I think even companies like HashiCorp, we haven't even talked about HashiCorp, but open source companies like what HashiCorp is doing for better delivery of apps on the cloud, as well as security. I think open source is something that we're going to see a lot more within this AI and ML space, and I think it's going to be an interesting next couple of years. Yeah, that's for sure. Masterly Interactive. I don't know why it's kind of hard getting you to be a speaker here, but Jordan, are you able to do that assignment?
Yeah, Jordan's the host.
Yeah.
So
I've not seen a request come through from Masterly. What's his name again? Could you just say it? Masterly.
Believe Masterly Interactive.
Yeah, I've not received a request. I received Fink's request come through, and I approve that obviously, but I've not seen Masterly's come through.
Gotcha.
Oh, right. Okay, I've seen it now. Okay. Yashar.
Yeah.
Okay. I've just approved that.
Yeah, I want to hear from these guys. These are some of the guys who do the groundwork every day. So Yash, I know, is a data scientist. And I know this is what he kind of does for most of this. I kind of wanted to hear more from kind of what you're seeing on the ground, Yash. Maybe just a brief introduction about yourself and just kind of what you're seeing in your day-to-day work as a data scientist.
Hey, thanks, Francis. Thanks for introducing me. Hi, everyone. I'm Yash, and I work as a data scientist at VantageScore Solutions. That's the credit scoring company. And I work, and prior to this, I've worked at Burlington Stores as well as a data scientist and at a horse racing algorithmic betting company. And these are the things I use usually on a daily basis. So you guys have already done a very good job of explaining what Snowflake does and its key and its financials and everything. But I'll give you one example of why these kind of companies have very sticky customers. So at my previous work, we were migrating from very legacy database systems to more on the cloud, using Microsoft Azure. So within Azure, there are a lot of different functionalities that you have in terms of choosing the uh, in terms of uploading your data and data ingestion related things. Then and a company like Snowflake integrates with all three cloud providers, AWS, Google, and Azure. And as these cloud companies increase their revenues, as their product is more widely used, more and more companies are shifting to the cloud. A lot of companies who have a huge amounts of data, where the data size goes on from billions to trillions of rows, end up using either Databricks or Snowflake for faster computation. Because what you can do is, at least Snowflake, their new product Snowpark, it also integrates with Python, and Python is one of the most common languages for a data scientist. So now, once you integrate Python with it, they have their own version of data frames, uh, which works well with the pandas data frames which Python uses. And apart from that, as the cloud companies grow their customers, more and more customers end up using companies like Snowflake. And as Snowflake mentions on their earnings calls, that their remaining performance obligations, like when customers start when they start their deals with Snowflake, the first 6 to 7 months go in their entire data migration, and the last half of the yearly deals is where they end up using their contract amounts. And that's why Snowflake, the RPOs for Snowflake are a big are a key metric during their earnings. So like in my previous role, we were migrating our databases from Oracle, from Netezza of IBM, and three other different databases to a one-stop shop in in Azure using Snowflake. And once, so it usually costs a lot, and it takes 6 to 8 months to move your entire data to such places. But once you move it, it's very unusual for the next 6 to 10 years for a company to go through that entire process again, to move to another database software, to uh, or non-cloud related things, because these cloud services, they might be expensive, but they save you a lot from paying different companies for different services, since they are a one-stop shop. And uh, companies like Snowflake, they help you read and work on large amounts of data within seconds, compared to the older ways where you sit and download data from some SQL server, upload it as a CSV. Those things take up a lot of time. So Snowflake and Databricks, they eliminate a lot of time in these kind of processes.
Yeah. Very interesting, Yash. Really, and it's kind of interesting, Yash. And this is kind of from my experience as well. Actually, so where I worked with Snowflake, I actually didn't get to see us using the final product because by the time I left my previous organization, um, we hadn't even finished. So that was actually something I didn't mention. It takes an extensive amount of time to get up and running on Snowflake's platform, right? And so in my organization, for example, I think it took us over a 1 year period between when we were like, hey, we're good, we want to implement the Snowflake platform, now we need to migrate all of our data sets that we had on-prem, as well as a little bit of what we had as well on AWS, but a huge part of our data sets were on-prem. And so we had to migrate everything over into Snowflake's platform. And that whole process required like a large project team, like a project manager, a project team to actually go about that work, because it's a huge process, and I think it took us over a year, if not even more, before we were actually able to get everything over into Snowflake's platform, and then begin using actual Snowflake's platform. So I think that's one of the craziest elements, and I just want to echo what Yash mentioned, is it takes such a long time. And after so just imagine a company has used over 1 year paying just to migrate your data, and then by the time you start using, what's the likelihood you're just gonna get rid of that platform tomorrow, you know? And then Snowflake even still makes some money off the migration, and they even haven't started making money on the actual running of the analytics and all your stuff you do on the actual platform. So this is actually one of the reasons why this stock is so expensive, because the growth runway and the retention and the low churn is just quite phenomenal, you know. Simon, I know you wanted to add
Yeah,
something.
yeah, yeah. I just wanted to say that I'm very surprised to learn that the bullishness for the Snowflake is just so it's kind of a consensus for us today, for all of the speakers here. But if you think about the public investors in general, their impression on Snowflake is kind of mixed. So I think it's a very interesting insight, because I think criticism and kind of skepticism is good when the stock is overvalued. And I think so far we are seeing that Snowflake is kind of fairly valued, because although we have the information edge, we are very much bullish on the Snowflake. There are tons of investors who are not familiar with this kind of pain point. They will kind of short or kind of go away with Snowflake based on its valuation. So I find it very interesting that we have a very consensus view around the future of Snowflake. And then maybe on to the data integration. It's also a very interesting part, because Palantir, according to their materials, they are able to integrate tons of legacy enterprise siloed databases together within a few months or within a few minutes. So that's a very interesting selling point for Palantir as well. But maybe they're just not monetizing that kind of capability well, much like Snowflake does. And another interesting part is that they have this kind of forward deployed engineers just kind of managing that kind of data integration process, but they're able to make it faster and make it more scalable with gross margin higher than 70%. So that's also a very interesting part of the story. And then maybe we have another speaker, Masli Inactive.
Yeah, very quickly before we go to Masterly, Yash, is there any other thing you're seeing kind of, and then like new tools? So let's just remove Snowflake, but like in general, are there new tools, are there new like apps, in terms
Yeah,
of
I
maybe
think
what you're
HashiCorp,
seeing?
as you alluded to, and then Kafka. I think we haven't discussed the Confluent. It's also a very successful open source based business. And yeah, I just find that the product is very organic as well, and it's very prevalent everywhere. I think it's even more organic than Snowflake. So maybe we can touch a bit around Kafka and Confluent as well.
Sure. We'll get to that. We're gonna get to that. Thanks for reminding me, Simon. And that's good. But Yash, very quickly, and maybe Yash, maybe it's open source project like what we mentioned that are trends. But what else? What else are you seeing in kind of where kind of what you do every day?
So what else would I see usually is uh in these kind of cases, like companies like so actually, your question is more towards Snowflake or just in general trends from like integration of data to the final machine learning models to all of it.
Yeah, I would say that I think we've had a really good conversation on Snowflake, and quite frankly, if nobody understands them, that's fine. But I think we've talked about Snowflake. I want to talk more about what are all the things that are happening within this whole ecosystem, from what you're saying.
So actually, these days, there is a lot of in terms of say Snowflake's data marketplace, there are a lot of companies which provide their data either free to use data, or some of them provide their paid data as well, and you can just request to them, send requests to them. So this data marketplace which Snowflake has, which is a very uh, upcoming thing where many companies are putting in their data, companies like Experian, companies like BlackRock, Square, they've all put their data in the Snowflake marketplace in some point. And earlier, Snowflake used to be criticized compared to Databricks in terms of their database related operations. So Databricks is created by Apache Spark people, and they use Spark. Spark data frames are a type of data frames, and Databricks uses those forms of data frames easily work with uh, easily work with large amounts of data. Now, Snowflake, as I was mentioning, Snowpark is the new product which is more of a competitor to Databricks Spark related data frames product, and you can and they have their own data frames, so you can work easily using those. And they have their own functions as well, and you can also use in SQL functions, Java functions, or different languages functions on Snowpark. So that's a very good integration it has. Then Snowflake also easily connects with Confluent, which is more into Apache Kafka, and that's actually created by the founders of Apache Kafka when they were at LinkedIn. So these days, a lot of companies are starting to use Confluent as well, or many of them just use open source Kafka. But then, as things get complicated, and they don't, and many of these companies, like consulting companies like EY, Deloitte, KPMG, they don't have the expertise on helping you use Confluent's product, or helping you use Apache Kafka, because that's still very new compared to all these other data related platforms. So when companies want to use Apache Kafka, the best expertise is Confluent. And I don't personally use that, but I've heard from other people that Confluent is like one of its kind.
Well, thanks. Masterly, I'm gonna get to you. I just wanted to really, you guys have brought up my favorite topic. I mean, I could talk about Confluent all day long, quite frankly. But I think Yash has just hit a good point, and this is really why Confluent has been really successful. Is as many people know, Apache Kafka, right? Yeah, and I think this is why I actually oh, I don't know if you guys have this shared on the space. But if you guys could see that data stack that I shared up on my tweet again, but Apache Kafka, you could think about it as a messaging platform. The analogy I use for people is think about getting your groceries from the store. You went to Walmart and you had like all your groceries in your big bag, and it's like so big in a box that you're like, okay, I gotta put this in like a bathroom, I gotta put this in the storage room, I gotta put this in so many parts of my house. How could I do it in an automated process? And so you think about implementing some kind of a robot to help you get all your big groceries from the store and then distribute it across your house to the right places that it needs to be after getting groceries. This is what Apache Kafka does. It's an open source. Meanwhile, it's free. It's open for people to use, And then what it does is it takes data from kind of your data sources. If you go back to my data stack, all of those data sources from your CRMs, from your applications, your ERP applications, and then it naturally distributes it into where it needs to go. So you could make your data storage. It helps to transform data in a much quicker process across your data warehouse, your storage locations, your databases. It helps to put them in the right places. And so, and that's the whole notion of event streaming. When you hear that word event streaming, or streaming or data streaming, that's the whole process. And this is what Apache Kafka does. But this technology is free. It's open source. That means it's free. But what Confluent has done is they've actually found a way to monetize this open source platform and making it monetizable. And so what they do now is they help companies that have a difficulty implementing these data streaming processes and kind of just distributing them across the organization in a real time. And that's the difference here is to making sure you're doing this in real time and with speed. Because with your traditional ETL process, you always have to have like a batch processing whereby data has to the way to go about distributing messages across the organization, it takes a lot of steps and it takes a lot of time for data sources to get into the right locations, like your databases where you need it for analytics. But with Apache Kafka, you speed up all of these processes. It's like life. It's like a stream. It's like this data in motion piece. But anyways, I think in general, I'm happy to hear as well that Kafka it's well adopted right now. Like it's a phenomenal product, and when companies have challenges with implementing Apache Kafka, that's where they get Confluent involved. And that's where Confluent has made a lot of the money. But yeah, we could talk more about that on the future space. Masterly, I want to hear from you. Maybe you have something to echo from our previous conversations on Snowflake or the trends, or do you have anything to add, or what have we maybe not brought up today that you would like to have? Because I know you as well follow this space closely.
Hi, Masterly, can you hear me?
Yeah.
Awesome. Thank you so much for having me. I think you guys already discussed most of the stuff on Snowflake. The only thing that I was going to add was, and I also think you mentioned this, is the converging of data warehousing and data lake. So traditionally, you had these on-premise data warehouse appliances like Oracle, Teradata, IBM had one. And then Snowflake came and they said, hey, we can modernize your data warehouses and we can take them to the cloud. And and we can manage for you. So as a data warehouse as a service, DWAS. But then when you look at the data warehouse in general, it's basically a storage system for structured data and sometimes semi-structured, but mostly structured data that you get from within the organization, whether it's the marketing data, the transactional data, the finance data, the sales data, whatever, and also some external data that's related to the company. But then who are the users of data warehouse in general? It's the decision analysts, right? The data analysts who are trying to create reports, who are trying to create dashboards, who are trying to do visualizations for business decision making. But then on the other hand, you have data lakes, which is basically the same thing, another storage system, but for unstructured data, raw data, like images, videos, text, whatever, audio, whatever you want to call it. And most of the users of data lakes are engineers, data engineers, and data scientists, right? Who are trying to either transform that data, that raw data, into something that's business data that can be used by the analysts, or do exploratory and then use the unstructured data or the raw data for training their machine learning models. But then, so if you basically one of those quote unquote typical data-driven organizations, you will have analysts, you will also have engineers and data scientists, who each of them will be using, the analysts will be using warehouses, and your engineers and your data scientists will be using the data lakes to do their machine learning stuff, right? The problem though is that you're going to use two different platforms. So for example, one will be Snowflake, one will be Databricks. You're going to be paying two different fees. But then the other problem is that these two teams or these two personas will be siloed. So there's going to be limited collaboration. So that was a challenge. Even when Snowflake and Databricks had an integration between themselves, it was still a challenge. So Snowflake did something interesting where they said, hey, instead of just sticking to modern cloud native data warehouse, how about we move across the other side and also have data lakes? Now we can handle unstructured data. We can appeal to other data users like data engineers and data analysts. And now we can be the full-blown data platform that we aspire to be, right? So that's one thing. And then on the other hand, Databricks did the similar thing, and they said, hey, how about we move across the pond and also not just stick to data lakes, but have data warehouses so that we can appeal to all users of data. And now you see there's this competition heating up between them. Before they were just two separate data storage architectures, but now they are converging. Each one is becoming a full-blown data platform, and it's going to be very interesting when right now neither of them is full-blown, but that's their ambition. So it's going to be interesting how that evolves. But I am very bullish on Snowflake, and I'm also very bullish on Databricks. And I'm not going to pick either of them until I see the financial metrics of Databricks and if they can become the full-blown data platform that they want to be. You know what I mean?
Absolutely.
Yeah, I think it's a kind of, I think Databricks calls itself the lake house. So that's the kind of the trend for the architecture to evolve into the future.
Yeah. Yeah, they started as a data lake, but if you look at some of their products right now, they have something like Data Lakehouse, which is basically a combination of data lakes and data warehouses. And that's what I mean by the convergence of the two different architectures. So you're not going to have, like 5 years from now, I don't think you're going to have a standalone data warehouse, a modern company. Snowflake will be more than a data warehouse, and Databricks will be more than a data lake. Each of them will be something like a full data cloud platform. You know what I mean?
Yeah, and it seems like we are just super early to this kind of adoption, and they are just innovating and building the new product and not even monetizing it yet.
Yep. But that's why I was saying, that's why, like right now, if you look at Snowflake as a thesis, it's more of like data warehouse. But if you want to invest in Snowflake for the long term, you see optionality, which is the data lake, which is becoming a whole cloud platform, and that's the real thesis. Like everything that's a data warehouse right now as a Snowflake is priced in as an investment. If you want to make a thesis, you should look beyond that. You should look beyond just the term of data analysts. You should look at the term, the total addressable market of as a all data users in the ecosystem?
Yeah, we have a huge runway for Snowflake, and I think that's a piece of information that public investors are not well aware of, and I think it's all about adding more value to the existing kind of commoditized data storage space, and in the future there will be more complex features and services introduced by Snowflake, and just as Yash kind of alluded to, it's also about like providing the high quality data to people, and you can kind of anonymize a lot of your consumer data and then share it on the marketplace and make it more usable to other people more easily as well. Yeah, and I think these are just very in-depth analysis over Snowflake, and I'm just very impressed by the kind of organic love from developers around Snowflake. Francis, what's your thought?
Yeah, I mean, I totally echo everything that you guys have mentioned. Quite honestly, not much to add, quite frankly. I think just to maybe we'll wrap up here in the next 15 minutes. I don't know if anyone in the audience has any questions for us. If there's anyone who has questions, like feel free to just raise it. Just like put a request to speak button. If there's anyone who has maybe something to add or maybe has a question, feel free to do so. But in the meantime, while we're waiting for anyone to ask a question, we're gonna wrap up pretty soon. Maybe Jordan, if you just want to finish up with like anything you have to add in terms of the chips, maybe just give us a high level pitch for kind of what you're seeing in the specialized chips in the semiconductors for machine learning. And then if anyone has questions, we'll take them, and if there's none after that, we'll wrap it up.
Yeah, well, just to, I know, Francis, you posted that diagram of the data machine learning industry, and that's very useful, but quite granular. I think at a higher level, you can just divide the industry that we're talking about into like the data collection and data cleansing, data preparation. That's kind of one component, and then you've got the training and the evaluation of machine learning models, which obviously will include a lot of the compute, the GPUs, CPUs, specialized ASIC chips, the TPU, which is Google's proprietary design, and then kind of another main area is kind of the deployment. Deploying this AI and machine learning models into production, whether that be at the edge or wherever in the web or wherever it may be. So I think having a high level view of the industry like that, kind of the data, like three areas: the data, the training and evaluation of models, and then the deployment. I think that might be quite useful for investors to use as a framework. And well, I mean, we could go in very deep into talking about specialized chips that are going to power machine learning. But yeah, I mean, generally, you've got NVIDIA. Obviously, they've got their GPUs, which are specialized, but kind of also we've got a bit of general purposeness with them as well, because they are very, very flexible, and that's why they are very prevalent across cloud computing. And then obviously you've got Google's TPU, the Tensor Processing Unit, as well, which is a very specialized ASIC chip designed especially for kind of matrix multiplication, like specifically for machine learning. So I mean, we could dive into that, but it's kind of a big topic. Simon's got a lot of thoughts on that as well. But what Fink mentioned earlier, he mentioned that applications, most applications don't have a machine learning AI component to it, which got me thinking, yeah, that's a good point. So maybe kind of on the machine learning side, we're most companies are still in the training the model stage rather than the kind of inference model stage, where the inference stage is obviously where the machine learning model, the AI model, goes out into the wild and is actually making predictions and being part of an application. So I think that's important. If you kind of think back, all right, okay, so machine learning, there's a lot of hype around it, but it's kind of people are still mainly training these machine learning models to refine them before they actually go into applications. That might help think about the chip industry. You know, what type of chips are going to be powering this machine learning at this stage, which is predominantly still kind of the training model stage. So, Simon, do you have any kind of final thoughts on chips?
Yeah,
I
just
mean,
very quick on the AI chip space. So I just find it very interesting that NVIDIA's moat is super deep here because of its CUDA and its tremendous amount of libraries, and its number of engineers is actually higher than most of other software companies. So they are really making the kind of using AI chip developing experience easier for a lot of developers. And I'm just very amazed by its capability to be on par with even the very cutting edge startups and the very ASIC like guys, because NVIDIA is more like the general purpose kind of chip instead of a very specialized ASIC. But its computing capacity and its kind of power efficiency and the kind of cost effectiveness is still leading the industry, and maybe Google's TPU, the Tensor Processing Unit, is close to it, but it's kind of confined within the Google ecosystem. Again, the vendor locking is a huge disadvantage for Google. And then thinking about the AI chip, the next would be the visionary startups. And I would just point out the TensorTorrent, which is joined by the Jim Keller from Intel and AMD. And Jim Keller is also the designer for Tesla's AI chip as well. So I think that is another interesting startup to watch. And overall, for the public available companies, I think NVIDIA is still a very strong vendor. And yeah, last year's appreciation for NVIDIA is probably too much around the AI and the metaverse. But going into the future, I just cannot see any other kind of established semiconductor company that is all able to beat NVIDIA from the AI side of the thing. Francis, any thoughts on that?
No, quite frankly, I'm not an expert in semiconductors. I mean, I've been to be really interested to get your perspectives on AMD, but I have a different thesis on AMD. I'm actually going to be covering their earnings report tomorrow. But quite frankly, semiconductors are not my space. They're not my specialty. So I beg to differ. And maybe in fact, I'd love to ask you guys what you guys think about AMD, the fact that they got approved for the Xilinx deal, and Nvidia didn't get approved. I believe they didn't get approved to get the ARMS chip. What do you guys think about AMD's competitive position, just more so in the AI side of things?
Yeah, AMD is also a very interesting player in the AI space because they also have that kind of graphics card route like NVIDIA does, but it kind of always trail behind NVIDIA in terms of the power efficiency and the kind of overall architectural design. And it's also the same for the AI space because they acquired ATI back in the 2006, 2007, that kind of time frame. And they were kind of distracted by that kind of concept called APU, which is to combine the GPU and the CPU together instead of focusing on developing the best GPU and CPU. And then they kind of did a revamp and asked the Jim Keller to join the company back again. And they had this Ryzen product, the CPU product that is able to deliver both cost leadership and the performance leadership against Intel. And that's their current focus. And if we are talking about AI data center chips, is most for AMD is mostly about getting its Ryzen CPU into the data center, and then it has a little bit of development around the kind of general purpose GPU to do accelerating the AI. But I just think they are not, it's not their core focus, and they are kind of riding upon NVIDIA's innovation because they don't have this software stack called CUDA to help developers develop AI applications on top of AMD chips easier. But we will see, and they have just announced a new deal with Meta, which is formerly called Facebook, around using their CPU, but also GPU to do the kind of AI acceleration. But I just think they are very early to this, and it's just a kind of optionality for them in terms of selling more GPU cards for AI accelerating. And even if it is for Meta, I find it very interesting that their most recent academic papers, they trained their model using TPU, using the Google service and the NVIDIA service instead of AMD. And even if Google is a huge competitor of Facebook, for Facebook's AI researchers, they still use Google's infrastructure. So it's a very interesting story as well.
Very cool. Very cool. Thanks a lot for that clarification, Simon. Okay, do you guys have? Was there any questions? Master Lee, Yash, are there any final words you guys have? Just wrapping up here. I want to make sure we finish this up at least within the next 5 minutes, or so. Any final words that you guys want to add? Anything that we've maybe missed? We haven't mentioned as much. And just final words.
Yeah, so last week we saw Microsoft had very good cloud related revenue. So now tomorrow and day after we have Google and Amazon coming as well. So those two, if their cloud results are very similar to Microsoft's, then that could be very good news for Confluent, Snowflake, Datadog, MongoDB, Elastic NV, and uh, companies which integrate with these three. But it could be bad news for DigitalOcean because they anyway have very less market share in this space, and probably, and then there are other private players like Heroku. But in terms of cloud and data related companies, these ones might benefit if Google and Amazon also have very similar results to Microsoft.
Cool. Cool. Yeah, totally echo that. What about you, Master Lee? Any final words?
The only thing I'm gonna say is, and we can discuss this another time because we don't have time right now, is consumption-based business model is gonna be a huge thing among infrastructure software. You already mentioned it in Snowflake. I think Databricks has it too, but a lot of infrastructure companies will and should adopt a consumption-based business model because it's much it aligns better with the value that's created for the consumers, and the more best-in-class companies adopt it, the better unfair advantage they get from their competitors who don't have as much of a good product as them. So That's my only other thoughts.
Absolutely agree on that. Yeah, it's gonna be really interesting. Consumption models have taken hold ever since, feels like since the pandemic. And yeah, it's going to be really interesting trend. Something we didn't even talk about is product analytics. Companies like Amplitude. And I don't know why, for some reason, when you mentioned that consumption business model as well, that's even another company that came to mind right now. But yeah, that's going to be really interesting to see who does well, the subscription guys or the consumption based business models. Right now, the consumption seems to be the trend, and many companies are adopting it. Yeah, it would be interesting. So yeah, no, that's good. Thanks. Thanks, Master Lead. Simon, and maybe Jordan.
Yeah.
Oh, sorry. Yeah, I was just going to just say thank you to everybody who's contributed. Master Lee, Yasha, Fink's gone now, but thank you. And yeah, Simon, any last thoughts before we round up?
Yeah. I just found that the kind of decoupling of compute and storage and the kind of cloud agnostic and the kind of the pain points that we have discussed today are highly relevant to the public investors. And yeah, there will be a huge tailwind for Snowflake and a lot of companies who are able to help developers make their life easier and solve their pain points. They will have a huge runway in the future as well.
Perfect. Okay, so just to wrap up, yeah, thanks again everyone for joining in. I really just appreciate you guys spending about an hour or so here with us. And as you guys know, I love to have these conversations with Convequity and Jordan and Simon, because these guys are one of the most deepest experts I know in technology, cybersecurity, and machine learning for the most part. So thanks everyone. As usual, I think we're gonna continue tweeting about these companies. Earnings are coming up for these companies, maybe not this week but the following week, especially for my SaaS companies. So I'm going to be tweeting and just sharing more analysis and insights of this company. And I'm sure Jordan and Simon, you guys could refer people to your Substack, and where people could find you, because I know you guys do a lot of deep work on there too.
Yeah, so we publish quite a few public articles on Seeking Alpha, and we also have quite a lot of free content on Substack. So make sure that you follow us on Seeking Alpha and Substack if you are interested. Yeah, and Jordan, do you have any final words?
No, I don't actually. I think it's all been well covered. So yeah, hopefully, perhaps we could have another Spaces chat in a couple of weeks, and we can dive into other areas of AI and ML, or we can discuss another area of enterprise software. So yeah, it's been great. Thank you very much.
Yeah. Thanks, everyone. And I think maybe we'll do this another time during earnings season when some of these companies have all reported. So, but yeah,
Absolutely.
thanks, everyone. Good morning, wherever you are. I know Simon and Jordan, it's morning over on your end. Good night to people who are on the East Coast, US, South Coast, evening. So, yeah, thanks, everyone. And yeah, have a good evening, have a good morning. So, thanks.
Okay. Bye.
Yeah.
Thanks,
bye.
everyone.